Hello everyone, let's study about combination of capacitors. To understand this, think for example like coins or like rupees. Say we have 1 rupee coin, say a 5 rupees coin, a 10 rupees note, and then say 20 rupees note, and then some multiples of it, say 50 rupees note and such things. Now we can't print every possible currency possible. For example, if somebody wants say 18 rupees, we can't print that amount of money or note or coin. So if we want 18 rupees, we take certain combination of these values. For example, we can take a 10 rupees note, a 5 rupees coin plus 3 1 rupee coins. This will give us 18 rupees. So the point here is we want a certain value of capacitance. So for example, I think the capacitance comes like 1 coulomb, say 2 coulomb, 5 coulomb, 10 coulomb, just rough examples. Don't have these values. Now imagine that we want certain value, we want something like say 8 coulomb or we want 12 coulomb. Now we can't make every possible capacitance value. It's not worth the time and then money spent on making them. So to obtain this, we need to combine them in certain combinations. That is called as capacitor combinations. So combinations is basically done to obtain a desired value of capacitance. Now this combination is of two kinds. So combination is of two kinds. The first type of combination is called as series combination. The second type is called as parallel combination. We'll see what these are one by one. In series combination, example of it's given like this. I'll tell you what it means in a minute. Something of this kind. So here we've taken three capacitors and let these capacitors be connected to a battery which can provide a potential difference of V. So this battery provides a potential difference of V. Let us call this as C1, C2 and then C3. Now what will happen here is, in this case, this plate of the capacitor 1 is connected to the positive terminal. So electrons are pulled from here. Electrons will start to go from here. They'll go on this plate. So this plate now becomes charged negatively. What will happen is this will induce a positive charge in this plate. Because of which electrons from here will go to this plate. That is, electrons from this plate will go to this plate, which means this becomes charged negatively, and by induction it will be charged positively. The electrons will push away from this, will go to this plate, and this becomes charged positively if the electrons are gone from there. So this combination where, and read out this combination where we call it C1, C2 and then C3. If charge on this plate is plus Q, charge on this will be minus Q. Because of this plate, charge here will be minus Q. This becomes plus Q, minus Q and then plus Q. So this combination where each plate has same charge is called as series combination, which means each plate will have same amount of charge, which is Q in this case. We can define series combination as telling that in series combination each plate will have each capacitor will have the same charge. You can also define another way, saying that in series combination the negative plate of one capacitor is connected to the positive plate of other capacitor. Same here also, negative plate of one capacitor is connected to the positive plate of the capacitor. So we can define this way also. The best way to remember this is think of, so water coming from a pipe. I think we have 3 pipes, something of this kind. We have 3 pipes, we call as pipe 1, pipe 2 and then pipe 3. In series combination, the water enters from here, the same amount of water flows through all the pipes. So you can think of the capacitor in series like the pipes connected here. So this is called as series combination, where all the capacitor will have same charge. Now recall here that Q is equal to C into V. C can vary, we can't control C because C depends on the plate dimensions, not on the battery or the charge flowing through it. So these capacitors can have same capacitance or different capacitance. Here we have taken 3 capacitors of different capacitances, so we can't alter with C. Out of these two terms, one would remain constant and one would vary. In this case, since Q is constant, V will vary, which means if this battery can provide a potential drop of say 15 volt, this would divide into 3 parts. The 3 parts could be equal or unequal. So if C1, C2, C3 are unequal, this will break up. So the voltage drop across these two capacitors, that is, if you put a voltmeter, the drop here will be called as V1. Similarly, if you take a voltmeter and measure between 2 points, any point here, a point here and a point here, it will be V2, and the drop between these 2 points would be V3. Keep in mind that the whole thing is wire. You can take a point here or here, could be anywhere. What we need is we need 2 points on the 2 sides of the capacitor. So don't always think that it should be only center of it. I can take a point here also. What does V1 mean is V1 is the drop across the first capacitor. V2 is the drop across the second capacitor. And V3 is the voltage drop across the third capacitor. Just think in that way alone. Now this total voltage drop, which is V, is equal to V1 plus V2 plus V3. So keep in mind that in case of series combination, the charge would be same, but the voltage drop would break up. This is called as series combination. Next case is, second part is called as parallel combination. To understand this, think of something of this kind, a capacitor like this and like this. We have 2 capacitors, we'll take 3. The 3 capacitors like this, and these 3 capacitors are connected to a battery, and this battery would provide a voltage drop of say V. What will happen here is, look at the plates, we'll call as C1, C2 and then C3. Now each of these plates, that is one of each capacitor plate, goes to the battery's positive terminal, which means this battery will pull electrons from all the plates. So some electrons will come out of this plate, some will come out of this plate, some from here. So at this point they'll join. If you call this point as say some point A, this is some point B. So electrons from here will come, electrons from here will come, and electrons from here also will come. These 3 would combine here and move together as single electrons, a single set of electrons. So if the charge on this plate is say, remember that if you have a conductor or capacitor, if electrons moves from a plate, for example, if electrons move from here, then this plate becomes charged positively, the other plate becomes charged negatively. So electrons are moving like this, but I told in previous lectures that by convention current is taken as flow of positive charges, which is opposite to the flow of electrons. So we tell that the charge Q is flowing like this. That's what we tell by convention, but practically what happens is the electrons are moving, which means the charge on this plate, if you call as Q1, charge here would be minus Q1. If charge on this plate is say plus Q2, it will be minus Q2. If charge on this plate is say Q3, it will be minus Q3. So the charge entering would be like Q1 and Q2 and then Q3. Now if you observe carefully, if the charge is Q, this breaks up. What I meant here is electrons coming from here will add up and go as capital Q. So total charge capital Q is equal to Q1 plus Q2 plus Q3. In case of series combination, the capacitors add same charge on each capacitor, rather they are different voltage drop. But in this case, each capacitor, that is across each capacitor, will have the same voltage drop. So if this battery can provide a voltage drop of 5 volt across capacitors, say C1, C2, C3, whether it is between these 2 points or these 2 points or these 2 points, it will have same voltage drop. It will be same as 5 volt only. So this combination where each of the capacitor positives, that is, this is positive, this is positive, this is positive. If all the positive plates of capacitors goes to single terminal, goes to this terminal, it's called as parallel combination. So here what happens is the charge divides. So we can define many ways. So one way you can say that the capacitors are said to be in parallel if the charge divides among them or if they are same voltage drop. To understand this, you can think of say 3 pipes connected like this. So there are 3 pipes, okay, like this. We'll call this pipe 1, pipe 2 and pipe 3. Suppose water enters into this pipe. Water finds 3 paths. So some amount of water will go into pipe 1, some goes to pipe 2, some goes to pipe 3. So here we have 3 kinds of orientation. So you can think of charge like water. I've been telling you that. Think of charge like water. So in this case, the water divides. So we can think of parallel combination as a combination where the charge would divide. There are same voltage drop. This is called as parallel combination.